The universe is a gigantic space with stars, galaxies, and probably lots of planets. Our tools and gadgets have given us loads of info about stars like our Sun, potential rocky planets, and the systems in our observable universe. But there's a big question. Are we the only ones? Even with all our efforts, we haven't found another world with even tiny life, like microbes. This big mystery is called the Fermi paradox, making us wonder how special Earth really is in the whole universe. There are many ideas, but we still need to know a lot more about the cosmos to get the answer. But what if there are others out there? That brings its own worries. What are these other smart civilizations like? Are they cool, or are they a danger? Are they smarter than us, or are we the brainy ones? And where in the universe can we find them? Make sure to watch until the end to understand what we know for sure, what we guess based on what we know now, and the huge parts of the universe we still don't understand. Only by exploring all of this, we can hope to figure out the secrets that cover our existence in this vast universe. The Fermi paradox is like a big question mark in our heads. Named after Enrico Fermi, it's about the strange gap between the high chance of other smart beings existing and the fact that we haven't seen or talked to any. Think about it. Our galaxy alone has tons of stars, and there are probably a crazy number of galaxies in the whole universe. So, where are the aliens? Enrico Fermi once asked a famous question: where is everybody? He wondered why, with so many chances for smart life out there, we haven't spotted any of it. The guy who started this whole Fermi paradox thing believed in aliens and thought we could travel in space. Since Fermi's question, we tried to figure out why the universe seems a bit lonely. Even on our best nights, we can only see around 2,500 stars, which is a tiny fraction of what's out there. But with 400 billion stars just in our Milky Way, there should be more going on, right? But here's the twist. He also thought maybe the aliens are just being quiet for now. Maybe they think we're not ready for a chat. This idea is called the zoo hypothesis. It's like thinking there might be higher beings out there who know about us, but choose not to talk to us yet. They might be waiting for us to get a bit smarter first. Now, let's talk about numbers and trying to figure out how likely things are. It's a bit like guessing, but we're using some fancy math to do it. First, there's something called the Drake equation. Back in the day, Frank Drake made this equation to guess how many civilizations might be out there. So we start with how fast stars are born, then figure out how many stars might have planets, and from those, how many could support life. It's a bit like a chain reaction of guesses. But here's the deal. The Drake equation is old, and it has some problems. It assumed only one planet per star system could have life, and that advanced life wouldn't spread too far. We now know that might not be true. So we're tweaking the equation a bit. We're saying, hey, almost every star has planets, so let's keep that in mind. With the new info from telescopes like Kepler, we know that a bunch of stars have planets around them. Now, we're guessing that about a quarter of stars could have planets that are just right for life. It's like narrowing down the possibilities. We're not stopping there. We're guessing that, on average, one of those planets is the perfect spot for life to thrive. It's like picking the golden ticket out of the bunch. Our galaxy, the Milky Way, has loads of stars, like way more than you can count. Experts say there could be 100 billion to 400 billion stars just in our galaxy. Wrap your head around that. But wait, there's more. There are not only a ton of stars in our galaxy, but there are also over 7 billion galaxies in the observable universe. That's a mind-blowing number. To put it in perspective, there are about 10,000 stars for every grain of sand on all the beaches on Earth. So, among all these stars, some might have planets similar to ours. Scientists think that around 1.1 billion stars in our galaxy could be like our Sun and have planets like Earth orbiting them. That's a lot of potential homes for smart beings, right? Now, here's where it gets even more interesting. Some say that about 22% of those stars might have Earth-like planets orbiting around them. This would mean there are potentially habitable planets around at least 1% of all stars in the universe. That's like having 100 billion Earth-like planets out there. Imagine that, 100 Earth-like planets for every grain of sand on our beaches. Now let's get into the Kardashev scale. Don't let the name scare you. It's just a way to measure how smart a civilization is. It goes from Type 1 to Type 3. With Type 1 being a civilization that controls all the energy on its home planet. Like it can handle earthquakes and control the weather. Pretty cool, huh? As we move up the scale, Type 2 is a civilization that can use all the energy from its star, not just its planet. Think about how much power that is. And Type 3? Well, that's a civilization that can control the energy of a whole galaxy. It's like next level stuff. Now here's the thing. With all these stars and the potential for smart civilizations, where are they? Why haven't we seen any signs or heard anything from them? So we still have to figure out if these smart beings are just really good at hiding, or if we need to look in different places. Now there is something called the Great Filter Hypothesis. It's a bit like trying to figure out why we haven't bumped into any smart aliens yet. Picture this: to become a super advanced civilization, you need to go through different steps. These steps include things like getting your act together as a society, using technology wisely, and not blowing yourself up. The last step in the journey is interstellar colonization, becoming a spacefaring civilization. Now, the Great Filter is like a checkpoint in this journey. It's a step that could be super hard to pass. If a step is too tough, civilizations might get stuck there and not move forward. So if we look at Earth's journey, we've managed to go through a bunch of steps: forming life, evolving, creating societies, and using technology. But the big question is, did we pass the Great Filter yet? Or is it still waiting for us in the future? Some folks think the Great Filter might be something really tricky, like avoiding climate disasters or not blowing each other up with nuclear weapons. If passing the filter is rare, then maybe there aren't many civilizations out there that made it through. Think about it like a game. If there's a super hard level, not many players might reach it. And if that level is a must to move forward, then we might have a clue about why we haven't met any other players yet. So, the Great Filter Hypothesis might be the reason why we're not hearing from other civilizations. Let's face it, looking for smart aliens is no easy task. The universe has been around for a whopping 13.8 billion years, and Earth is just a tiny fraction of that. We got all this advanced tech, and yet, nada. No signals, no visits. Now, let's think about time. Earth has been around for about 4 to 5 billion years, and our civilizations have come a long way in just the last few hundred years. Imagine how much civilizations 500 years ago differed from us. If other beings are out there, maybe they're at a totally different level than us, making it tricky for us to communicate. So, as we keep exploring, it's definitely a great paradox. We might discover pals out there, or we might be the cosmic oddballs. Either way, it's a journey worth taking. If you enjoyed this video, don't forget to hit that like button and subscribe for more. Thanks for watching, and we will see you in the next one.